Okay, so today we're going to be looking at section 6.1. We're going to look at the definition of the trig functions for any angle. So we do the basic trig function ratios off of a right triangle, which means all the angles we used were acute angles, angles less than 90 degrees. So now we're going to look at all types of angles. Okay, and so we need to start off with what is an angle in standard position. So here's an angle in standard position, angle theta. An angle is in standard position when the vertex of the angle is at the origin. The initial side is on the positive x-axis. That's the initial side. So this side never moves. It's always right here. And it's the terminal side is that's sweeping around, creating angles. So the terminal side will sweep in a counterclockwise direction and creating an angle between the initial side, and that is an angle in standard position. Okay? So there's different kinds of angles we're going to be looking at, positive angles and negative angles. So a positive angle is an angle that's in standard position, and the terminal side rotates in a counterclockwise direction about the vertex or the origin. Okay? So it's sweeping in this fashion like that. That creates a positive angle. As you can see down here, this symbol right here is an alpha. So usually we start with theta, then we'll do alpha, then we'll do beta, and those are the main angle names that we use. There's other ones we use also, but we'll talk about those in a minute. Negative angles. I can have a negative angle. A negative angle is an angle that sweeps in a clockwise direction. So the terminal side now will sweep in a clockwise direction about the vertex, and those are how we recognize negative angles. So down here is an example of a negative angle. So we're sweeping it in this direction. So this angle beta would be a negative angle. And it can be in radians or in degrees. Either way is fine. So another name we need to know is coterminal angles. What does that mean? Coterminal angles are angles, two or more angles, that have the same initial side and the same terminal side, but they have different measures in their angle. So here's an example. This example right here, alpha is this angle right here, from here sweeping in a positive direction. And then a negative angle, beta, ending at the same terminal side. They have different measurements, but yet they are coterminal because they end at the same location. I can also lap, so in other words, here's an alpha angle, okay? And then the beta goes all the way around the circle one time and then stops there. And so then that would be a different measurement, yet starts and stops at the same location. These two angles would be coterminal. And that's going to help us find answers to many things, many trig ratios for different angles. So this coterminal idea is very important to understand. The next thing is, what is the definition? Well, we normally did our trig ratios in a right triangle, and we still need a right triangle, but now we're going to do it from any location. So here it is, the definition of trig functions for any angle. Here's all 6 of them that we're going to be dealing with. So I have an angle in standard position, so I just drew this one over here, where the angle terminal side is in quadrant 2. Here is the angle theta. Here is a point on the terminal side. The distance from this point to the origin, using just Pythagorean theorem, gives me this relationship right here. Okay, because this distance here is x, this distance here is y. X squared plus y squared is r squared. Pythagorean theorem. And so if you look at this, you'll see that there's a very close similarity to what we did before, where we did opposite over hypotenuse and things like that. The hypotenuse is r, and the angle theta right here, and then we have, so in this, if you look at this triangle right here, you will see that we can use our right triangle concept, because this is a right angle right here, to help us determine these values. So the thing to watch out for, though, is x distance. It's a value. It's a value of this point. So it's going to be, there can be negative values. When we had right triangle trigonometry, everything was in over here in quadrant 1, so everything was positive. But now I'm going to start bringing in negative values. So you have to keep that in mind when you write your ratios. So the y value of the point over r. Well, the y value would be here. So this thing right here kind of represents what's called a reference triangle. And this one here would be a reference angle, usually designated with a prime. Okay. So this is the angle, though, it's theta. There's no theta prime in here. But I want you to know that the trig ratios for these two angles would be the same. Okay, so that's how that works. That's why it works this way. So y over r. So from here, y would be opposite. R would be the hypotenuse. So that's why it's still the same thing. Opposite over hypotenuse, or y over r. Cosine, this side right here is adjacent to the angle, so then it would be adjacent over hypotenuse, and so forth and so on. So it still matches the same ratios that we had before. It just now extends to all angles and everywhere in the coordinate plane, as long as the angle is in standard position. So that's how that works. So the sine of an angle is the y value of this point over the length r. X over r is the cosine. The tangent is y over x, opposite over adjacent. And then these ratios over here are the reciprocals of these ratios over here. So this is called the cosecant. And if I didn't write this name out before, I will now. It's called the cosecant. This one is called the secant. And this one is called the cotangent. So the cosecant of an angle is the reciprocal of the sine of that angle. And we'll explore this concept in much more detail later. So for right now, just keep in mind that we're going to do the reciprocal action form. So usually what we do is we find these three first, and then flip them all over to produce these three over here. So the next question is, how do you know which one goes with what? Well, you can try and memorize it however you want. What I simply do is this. This starts with an S. This one starts with a C. This one starts with a C. This one starts with an S. So you have an S and a C for each relationship. And then this was pretty obvious, tangent, cotangent. That one's pretty obvious. So that's how I remember which one is which. It goes with which one. You can do it in any fashion that you want. So that's the preliminary information. We're going to do some problems associated with this information. So let me show you that now. I'm going to go through the classwork over here for you guys. And so the first thing they want you to do is they want you to, for each angle down here, sketch the angle in standard form, identify which quadrant that the angle lies in. And so let's draw a couple of these things out. I'll do a positive one and a negative one. This is where the unit circle stuff comes in for you. You want to make sure you memorize the unit circle. So let's start with number 1. Where is 5 pi over 4 in our normal coordinate system? Okay. You can memorize this a couple of different ways. You know that all the way around is 2 pi. So this would be like 0. And then over here is pi. And then back over here is 2 pi. So think of forget the pi, think of the fractions. This is 0, this is 1. Well, that is, the 5 over 4 is 1 1/4. Okay? So if this is 1, then 1 1/4 will be in here somewhere. Okay? And so you can break this all up. So if this is 1, then this is 1/2. And this would be 1 1/2, which we write as 3 pi over 2. So that's kind of how that works. Okay? And so then we have 4, so that cuts everything up into quarters in this fashion. So this is 1, or 4 over 4. This is 6 over 4. So that's 4 over 4, and that's 6 over 4. Then 5 pi over 4 must be right in the middle. So this is the terminal side for this angle right here, which is 5 pi over 4. So theta is 5 pi over 4. And this quadrants are, this is Q1, quadrant 2, quadrant 3, and this is quadrant 4. So our angle theta, 5 pi over 4, is in quadrant 3. And that's how you would draw it. Okay? Let's do a negative angle. We'll do negative 36 degrees. Again, remember, this is 0. And in degree fashion, if I was going in a positive direction, this would be 90 degrees, 180, 270, and back to 360. So what does the negative angles do? Well, it's just the opposite of that. So if this is 0, and this is always 0, going in this direction, this would be negative 90 degrees, negative 180 degrees, and so forth, going in that fashion, in a clockwise direction. So negative 36 is somewhere down here. So we would just draw a line over here. This angle is the angle right here. Theta is a negative 36 degrees. And we can see that we are in quadrant 4. So that's how you do negative angles. Okay? And so you can do the other ones if you want to practice more. If you have questions, we can ask them during class. Let's drop down to the next part right here, where I'm asking you to determine coterminal angles. I want coterminal angles. I want one to be positive, and I want one to be negative. So there's an infinite number. So for 45 degrees right here, there's an infinite number of coterminal angles to this angle 45 degrees. Infinite. You got positive angles, you got negative angles. There's an infinite number all the way around. So how do I get to these other coterminal angles? So let's just do the 45 since I talked about it first. So first off, where is 45 degrees? Well, here's my 0 degrees right here. Okay, this is 90 degrees up here, so 45 is right in the middle. So this angle right here is 45 degrees. So coterminal means I'm going to go around. So I can go in a positive direction to get back to this line. I can go all the way around the circle and then up to that line again. That would be an angle that is coterminal to 45 degrees. Well, coterminals are basically determined by how many times you go around the circle, how many rotations do you make. So if I go in a positive direction, if I make one rotation, then I can get to the next angle that's coterminal to this is by simply taking the 45 degree angle and adding one revolution to it. And one revolution in degrees is 360 degrees. So I can add these two numbers together and I can get my answer, which is what, 405. So there, 405 degrees is an angle that is coterminal to 45 degrees. Okay, and so I can also get a negative angle by simply taking the 45 and going in a clockwise direction, like that, starting at 45 and going around one time in a negative direction. So 45 degrees minus 360 degrees. And you can see that I'm going to produce a negative value here. What do we get here? I think it's what, 315? But a negative 315 degrees. And so that's how that's done. Okay? You can just either add or subtract. And sometimes you might need a multiple of these. So we can look at different angles over here and try and find ones that give me a positive or negative. Let's take a look at this one right here where I had number 6 was a negative. Sorry. Let's do this right here just because I want to show you. I know it's not a, but I want to show you what happened here. So if I do a negative 420, if I add 360 to this, what's going to happen is I'm still going to have a negative value. I'm going to get a negative 60 degrees. Okay, remember I wanted one positive and one negative. So how do I get to a positive one? I added one time around and I still got a negative angle. So all I have to do is simply add 2 times around the circle. So just go around the circle one more time. So this right here is 720. And so if I add 720 to negative 420 degrees, then I'm going to end up with 300. And so now I have a coterminal angle is 300. Negative 60 is coterminal to 300. Negative 420 is coterminal to both of those. But here's one positive and one negative. So you just do a multiple around until you get the positive and or the negative, depending on what you're starting with. And the same thing applies with radian measurements. You're just going to have to deal with the fraction part of it. Okay? If you add around, remember you're adding a 2 pi. So let's go ahead and do one of those. We can do the negative 2 pi over 15. So I have negative 2 pi over 15 is my angle that I'm starting with. I can draw that in standard notation if I wanted to, but I don't need to do all that. I'm going to start with 2 pi over 15, and I'm going to add 2 pi to it. Okay, well, forget the pi's are just there. Just think of it as fractions. So I have a negative 2 over 15, and then I'm going to change this to 15, so that's going to be a 30 over 15, which gives me 28 pi over 15. If you can reduce this fraction, you do so, but it's not going to reduce. And so there is my positive coterminal angle. Just like for the degrees, how do I get a negative one? Well, subtract 2 pi. So I have a negative 2 pi over 15 minus 30 pi over 15, which gives me a negative 32 pi over 15. And again, can I reduce this? And the answer still is no. So here's one positive, one negative that are coterminal to this angle right here. Okay, so that is how I draw angles in center position and know what quadrant that they're in, and to be able to start visualizing these angles without having to draw them, and then how to find coterminal angles, because that will also be useful to us in the future also. So the next one here is finding the 6 trig ratios based off of information. So the information you're given this time is, I'm giving you a picture. Here's the terminal side of an angle that I don't know. But I do know that the point 34 is on the terminal side of this angle. So from that, I am able to figure out all the trig ratios, because the trig ratios are based off of the x and the y value of that point. And so all I have to do now is find this distance. What is the distance between these? So the process you follow is this. You draw your picture, drop this down as a dotted line, and make a right triangle. You're always going to draw from the point to the x-axis. It's always to the x-axis. That's your right triangle. This distance, this number here will be the x. This number here will be the y. Whether it's positive or negative, don't change it. You're in quadrant 1. You got to keep eye of your signs. So my r, in this case, you got to find r, is the square root of 3 squared plus 4 squared. You work that out and you simplify this radical. Do not give it decimal. Give it as a simplified radical. This is 9, 16, that's 25, so this is going to be a 5. This number here is 3. This number here is 4. Okay? You can put it there if you want, 3 and 4. And so then, what is my sine of this angle? The sine is y over r. Y is 4, r is 5. The cosine of this angle is x over r. The tangent of this angle is y over x. And then I come over here for the other one. The cosecant is the reciprocal of that. So I know it's going to be 5 over 4. And the secant is the reciprocal of the cosine. So I know it's going to be 5 over 3. And the cotangent is the reciprocal of the tangent, which is 3 over 4. And there is your 6 trig functions. Okay? So what if the angle's in quadrant 2? So now I have x is a negative 2 and y is a positive 3. The process is exactly the same. Drop a right triangle to the x-axis. So this value that we use here for this is negative 2. This value is 3. We still need to find r. And so r squared is negative 2 squared plus 3 squared. So that's going to be 4 plus 9, 13. So r is the square root of 13. And once I have that, then I can do the 6 trig ratios. Again, the sine of that angle is y over r. So it'll be y over the square root of 13. The cosine is x over r. X is a negative 2 over the square root of 13. So you got to put that negative in there. The tangent is y over x. So that'd be 3 over negative 2. And then the other ones are just the reciprocals. Now I'm leaving a little bit more room here because you actually are going to have to rationalize these denominators in just a moment. But do the other 6 trig ratios first so that you don't have to do extra work. The cosecant is just the reciprocal of this. So reciprocal at first, and then we'll go back and rationalize last. Always do rationalizations last. Never do them first, because you'll just have to do it again over here. If I rationalize this, then the radical will be on top, and then if I flip that over, you put the radical back on the bottom, which means I got to rationalize over here too. Whereas this is just going to be much easier. When you write the trig ratios, make sure you have the trig name and then the angle. There must be an angle. If you don't put the angle, it's considered wrong. If I just have that, it's wrong. Okay, you got to have an angle sitting here, and that's how that works. So this is what we're going to be doing here in the first section, and so make sure you write down the notes and the process that we talked about. So the process is, you're going to do what? You're going to drop a triangle, drop a right triangle to the x-axis. It's always to the x-axis. Okay, you want to find r, Pythagorean theorem. Okay, and then use the definition. Watch your signs. That's usually the number one mistake people make, is they forget about the signs, that they're in quadrant 2, that the x has to be negative. Okay, so the signs are usually off. Oh, I forgot to rationalize. So the rationalization is going to multiply the top and bottom of this thing by the square root of 13. And so what it basically does is the square root of 13 will go to the top, and the bottom just becomes a 13. You'll still need to make sure that this does not reduce. So if this reduces, you got to reduce it. But that's pretty much all that happens. So this is 2, the square root of 13 over 13. And so you want to make sure you rationalize them. And I'm fine if you can see that you're going to go from here to here, I'm fine with that. Okay, so be careful, watch your signs, and we'll do more in class.